Welcome back to investigating Hadoop logs with LogDelta. Part 4, line-by-line anomaly scores. Next, we analyze each log line in isolation and assign an anomaly score to each line. LogDelta provides these line-level anomaly scores as Excel or CSV files. However, a practical starting point is to use visualizations. These visualizations create a unique fingerprint for each run, making it easier to identify deviations. On the screen, you can see both a spreadsheet of log lines and a visualization of log lines. It is important to highlight the distinction from the previous video. In that approach, we evaluated the entire textual content of a run and assigned an anomaly score to the run as a whole. In contrast, this line-by-line approach focuses on individual log lines. The difference is notable. The previous model answers the question, is this entire run anomalous? Whereas this model answers, is this specific log line anomalous? The advantage of the line-by-line approach is its ability to pinpoint exactly which lines are anomalous, providing more detailed insights into the data. This model is specified in the file for ano_line_content.yml. For line-level predictions, we need to select a specific log file to analyze. In this case, we build and test models using the main log file, container_01_00001.log from all runs. This log file is the largest for each run and can be considered the main log that spawns worker processes. To generate results, execute the command python-m logdelta.configurunner-c4_ano_line_content.yml. The output will be saved in the out4 folder. Now we have the results. Let's open one run line-by-line visualization log labeled as normal, namely page rank, normal chess application 144518 21591191900012 to explain what is visualized. First, x-axis corresponds to the line number, while y-axis shows the anomaly scores. Anomalies are scored with the 4 anomaly detection models k-means, isolation forest, rarity model, and out of vocabulary detector. We have also added their moving averages over 10 and 100 log lines. All anomaly scores have been normalized from 0 to 1. Otherwise, reading this would be impossible, as each anomaly detection method scores anomalies differently. It is a good idea to check each anomaly model's scores individually first. We can observe that k-means and isolation forest show more fluctuation in their scores compared to the rarity model. Additionally, we notice that the out-of-vocabulary detector does not detect any out-of-vocabulary terms in this file, as it assigns a score of 0 to every line. We can check out some individual points. Moving the mouse over a point brings up a tooltip that displays the log line in more detail. Examining a few points reveals that the higher scoring log lines do not appear to be particularly alarming. Looking at the moving averages, we see that the isolation forest and k-means models give this run almost identical scores. The rarity model is somewhat different, although it shares some similarities with the patterns from k-means and isolation forest. However, the out-of-vocabulary detector consistently scores 0, providing a clearly distinct pattern.